We have 25 milliliters of an unknown solution, so we're going to need that at the end. But what we need to begin with is 25 milliliters of a 0.05283 molar EDTA solution. The fact that the pH was buffered to 5.5 really isn't relevant for your problem solving, but the back titration is. So this is one of those problems where you have total EDTA is going to be equal to the EDTA that reacts with the zinc, so the excess, which will be represented by the zinc, and then we have the EDTA that reacted with the nickel. So the total EDTA is going to be represented by this stuff here. So let's calculate that first. We have our 0.02500 liters of EDTA. That's the milliliters converted into liters. And we're going to multiply that by the concentration, 0.05283 moles of EDTA per 1 liter of EDTA. That way the liters of EDTA cancel and we are left with moles of EDTA. So the total moles of EDTA added are 1.32075, those are all of the digits in my calculator, times 10 to the negative 3. So that's total moles of EDTA. Now the excess EDTA is going to be represented then by what was back titrated. So the 17.01761 liters of zinc, 17.61 milliliters of zinc with a molarity of 0.02299, and that's moles of zinc per 1 liter of zinc solution. That way our zinc solutions cancel and we're left with moles, but we don't want moles of zinc, we want moles of EDTA. Now we know that EDTA reacts in a 1-to-1 with all of our metals. So 1 mole of zinc reacts with 1 mole of EDTA. That way our moles of zinc cancel and we're left with moles of EDTA. Remember, when you have your total moles of something, you can only subtract moles of that. So we need our moles of EDTA. So the excess EDTA found by this calculation here, I get 4.048539 times 10 to the negative 4th. And again, that's moles of EDTA. And that represents the excess. Let's see if I can get this to stick. So we have mole excess here. So now we can calculate the EDTA, the moles of EDTA that reacted with our nickel. And this is just a subtraction problem, 1.32075 times 10 to the negative 3rd minus our excess, 4.04, etc. And so the EDTA that reacted with the nickel is going to be equal to 9.158961 times 10 to the negative 4. And again, that is moles of EDTA. So now let's go back to our problem. The problem asks us, what is the unknown concentration of, and that would be in the original unknown solution. Well, what I have here are moles of EDTA. So I need to convert those moles of EDTA to moles of nickel. Now we know that 1 mole of EDTA reacts with 1 mole of any metal. In this case, we're looking for nickel. So I have this value, 9.589, etc., times 10 to the negative 4 moles of nickel for my unknown. So I need to divide that by the volume of the unknown. The original volume of the unknown was 25 milliliters. So I convert that into liters, 0.03663. Oh, that's the answer, 0.02500 liters. And I get the molarity, which is 0.0366. And then I have 35. So I would, and it continues from there, it's 358. So I would round up here and report 0.03664 capital M molar, and that is the concentration of nickel in the unknown.